Hello, everyone. Welcome to the first winter and only winter webinar for GCAN for the Gulf Coastal Acidification Network. For those who don't know me, my name is Dr. Natalia Lopez Figueroa, and I'm the acting coordinator for GCAN. And today we have the great honor and I'm very excited to present Dr. Gilberto Cardoso. And he is a full-time researcher at the Marine Limnology Center at the Autonomous National University of Mexico. And just to summarize some of Dr. Cardoso's work, he is a biochemical modeler specialized in water quality in aquatic ecosystems. And Dr. Cardoso stands out because he combines chemical training and mathematical/computational modeling, which allows us to tackle complex and cross-disciplinary problems in marine science, especially ocean chemistry. His long publication record and involvement in diverse but interconnected research topics makes him a significant contributor to marine and coastal environmental science, and especially in Latin America. So I'm very excited for everybody to listen to what he will be talking about. So without further ado, Dr. Cardoso. Just so you know, everybody, I will turn on my webcam. I will let you know when we're like 5 minutes out or 10 and 5 minutes out. And for everyone, please type your questions in the chat. I can read them to you, Dr. Cardoso, because I don't think you will be able to see them, if that's okay.
Okay, thank you. Thank you very much. Thank you for
Yes.
the invitation. Okay, Términos Lagoon is the largest estuarine ecosystem in the Gulf, in Mexico. So it's located in the south of Gulf and is near to Yucatán Peninsula, the Karstic ecosystem of the Yucatán Peninsula, and also receives water from the two main rivers. The Palizada River has the 70% of the fresh water right from the Palizada River. The Candelaria River is almost 20%. The Candelaria River is inside, the Candelaria River bed is inside the Yucatán Peninsula, so it's more karstic, percent more karstic. Is more karstic than the Palizada River. Palizada River is a classic river. So the Palizada River flows approximately 4 times more than the Candelaria River. And also is connected, the lagoon is connected with the Gulf through the 2 mounts. This is the Carmen Mount, and this is Carmen Mount, and this is I forget. Okay, this is 2 Mount. Okay, to evaluate the variation of the carbon dynamics in the lagoon, we measure total alkalinity and DAC from the Palizada River inside the Palizada River bed and the Candelaria River. And we have 2 transects in the 2 mounts. Is La Guada Mount. So this is the Carmen Mount and is La Guada Mount. So we measure in these points TA and DAC during 2 seasons, dry and rainy season. First one, the relation of TA and DAC presents almost a linear tendencies, which that's indicated despite the lagoon have a lot of carbon sources, the inorganic carbon is driven by carbonated system. Also, very strange results, the high concentration of TA and DAC was presented during the dry season, okay? Also, during the dry season, the Candelaria experienced a saltwater distortion. This one, these values inside the river present high concentration of the salinities indicated. This is salt water. In rainy season was fresh water, whereas the Palizada River remains freshwater condition year round. So the Palizada is almost fresh water. What happened with the TA and DAC? Although the Palizada although the Palizada River has greater flow than the Candelaria, the highest concentration of total alkalinity and DAC was presented inside the Candelaria during the dry season. So that indicates that high concentration of the TA is not from the river flows. So the idea is the river receives significant flow of Karst groundwater from the Yucatán aquifer. We calculate TA minus DAC, which is is an indicator of negative PCO2. So if we have a negative value of PCO2, we have high concentration of CO2. This is an approximation, right? It's not exactly, but it's an indicator. So the results indicate the negative value of TA minus DAC presented in the water with almost zero salinity. So the highest concentration of CO2 are presented in the fresh water. The most area, the area with the highest concentration of CO2 was the Palizada River. So in the river channel of the Palizada River, okay? How much is that? The PCO2 in the Palizada River reaches to 8 atmosphere or 8,000 atmosphere. So during the rainy season, yes, this is the peak. How much is that? For example, for comparison, in a typical river with high concentration is 3 atmospheres, okay? And in the Mississippi is almost 2 atmospheres or 200 microatmospheres. That is surprising because Palizada River doesn't have high concentration of organic matter. What happened what could be the source of this high organic CO2, high CO2? In Karstic ecosystem, the atmospheric CO2 or the CO2 from organic matter oxidation can dissolve the organic carbon, the organic, the lithogenic carbon, can dissolve the carbonate calcium, producing calcium, and this produces these capes with high concentration. The next process is the calcium carbonate precipitation release CO2 again. So for example, this is a beautiful area in Playa del Carmen. This is a cenote. So the increase of CO2 produce the dissolution of the weathering of the rocks, and in the groundwater, this CO2 can be released. So what is the idea? Maybe the Palizada River have 2 different sources of CO2. One is from the organic matter oxidation transported by the runoff. That is biogenic origin. And also this area has karstic. Karstic is a karstic ecosystem. So they receive groundwater from, they receive CO2 from the groundwater. That is organic lithogenic CO2. This combination could be the highest could be the cause of this highest concentration of CO2 in the Palizada River. So what is the implication of these results? The Yucatán Peninsula is constantly dissolving and releasing CO2. This is normal. This is the reason because we have cenotes and this is La Colorada and Peninsula. This is normal. So the Yucatan is releasing CO2 to the coastal area. This process could identify as atmospheric CO2 level rise. So these processes, okay? This CO2 and this is atmospheric CO2 can release more. This CO2 can dissolve the limestone of the karstic ecosystem, so produce more CO2. Also, we have a lot of discharges of organic matter, and from urban organic matter, we discard urban organic matter or agriculture to the aquifer. So that process can be intensify these CO2 releases. So this is the question. The Yucatán Peninsula can be a significant source of CO2 to the Gulf, affecting carbon budgets and the ocean acidification. This is part of the data and conclusion can be consulted in this paper, okay? And also, if you want to contact me, this is my email, and this is in this link. You can check the raw data and Python calculation from this paper. And thank you very much.
All right, that was great. That's so interesting, especially in a lot of the karstic formations. I wonder how that, so the northern end of Puerto Rico is made of karst, basically. So it's interesting to see like what impact could that have in like coastal plain estuaries, that groundwater is the main source of fresh water in the estuary. Like how would the CO2 levels vary? Let's see. Do we have any questions that I'd like to ask? Dr. Kim Yet says, very good work. Have you tried plotting salinity, normalized total alkalinity, and DIC to estimate the ratios of net ecosystem calcification to net ecosystem productivity?
Sorry, is plot what?
It's, have you tried plotting salinity, normalized TA, and DIC to estimate the ratios of net ecosystem calcifications to net ecosystem productivity?
Ah, okay. Yeah, I showed that. I showed that kind of plot. No, we didn't. But yeah, this is a good idea. This is, I know that is a plot. Yeah, I remember in a paper. This is a plot with the source of the CO2, right? From primary productivity, and it's from normalized salinity normalized.
TA, it says here, salinity, yeah, plotting salinity normalized TA and DIC to estimate the net ratio, the net ecosystem calcification and net ecosystem productivity. They say you have a beautiful data set that lends itself to that analysis.
Yeah, that is a good idea. We didn't, but I think we can that. Yeah, sure.
Yes.
If the professor have some paper from that, it could be better.
They just said I can send along a reference for that process if you'd like. So yes. Thank you, Kim. Do we have any more questions? Says many thanks for the presentations. That's Dr. Kim Yates. Thank you so much.
Thank you so much.
Let's see if the chat. So do you have some, is this what you're currently working on, or was this part of your dissertation?
I'm living in the Ciudad del Carmen, so I'm living in the Términos Lagoon. Yeah, it's part of my regular
Regular research.
Yeah, yes, it's part of my specialty is not in organic carbon system, but I use biochemical modeling. So I use the next step is modeling this one. So, but the next step is measure the total alkalinity and DC, and the next step is modeling the carbon flux in the biochemical modeling.
It would be really interesting to see some preliminary modeling in the future. If you'd like to give like a part 2 to your webinar.
Oh, yeah.
Yes. It was really really quick too. Like it was you compacted in such a good way. Like the story was told in a very nice manner. So if you have anything else that you'd like to share, and then Kate Rose said she please share the link to the paper. Kim Yates asked, were all of your measurements at the surface or some at the seafloor? I may have missed that.
Yeah, we have two samples in the surface and bottom. The average depth in the lagoon is 3 meters. So in some area we have 1 meter depth. So it's replication. But some area we have, for example, 4 meters. So we don't have too much difference between surface and bottom. The Términos Lagoon is very shallow and it's huge. So we have a lot of mix in the we don't have a stratification normally. In the river plume, yes, but it's from the all of the lagoon is we don't have a stratification, thermal stratification.
Thank you so much for that. Thank you, Kim, for asking the questions. So what are the next steps that you plan to take with this project?
Yeah, I have a crazy idea. I don't know, but I want to calculate. It's theory, yes. I want to calculate the total flux of CO2 of the terminals of the Yucatán Peninsula to the Gulf. So they are a model. This is a Karst ecosystem. So it's like a sponge. It's a lot of caves. So they are some models and measure, and they calculate the flux of the Yucatan aquifer, more or less. So they are data. Maybe we need to refine this model, but we have the flux in great numbers. So my idea is measure in different parts of the peninsula the concentration of TA and DAC, maybe pH for more detail. So in theory, we can measure the total flux of the peninsula to the Gulf. This is a crazy idea, but I think it's possible. So it's a good calculation for the whole budget of the Gulf.
would that be surface or just in general, like would you do like a profile of different of that area, like of the different areas?
My idea is go to the cenotes, no? I don't know what's in English, cenotes.
I don't know either.
Okay, cenotes is this cave, beautiful cave. They are closed cenotes, right? So these areas is very good because you don't have any interchange with the atmospheric. So in theory, this CO2 is a capsule of the concentration. My idea is measure near to the coast in this capsule of the CO2. This is cenotes, close cenotes. So it's in these areas. The cenotes could be very deep, but I think maybe in not too much samples from in the depth, because I think it's better use more points around the peninsula, but this idea could be very complex. This is my crazy idea, but that could be very good approach to evaluate the budget of the dissolution. Also, we can calculate, I think we can calculate modeling the increase of the dissolution from the increase of CO2, atmospheric CO2, I think, in a model. This is a Christmas idea, so this is good.
So
yeah.
Are you familiar with the Gulf Acidification Network at GCAN? It's okay to say no if you don't.
Oh yeah, yes, but I read the papers, I read the page, but not with. I think I know some people, but no. In short answer, no.
Yeah, so we are currently working on a story map with data from the Gulf related to the carbon system, and there's this cruise called the GOMEX series. It's the Gulf. It's for acidification measurements in the Gulf. They were supposed to go on their 5th voyage, but they couldn't go this year. But we're plotting that data in a story map, and with that in mind, so we serve as like part of our mission is to have data available to others that could be useful. So how can GCAN support the development of like a Gulf-wide carbon budget that include this terrestrial input? Like, do you have an idea of how could, like, what would be helpful to you as a stakeholder, like for us to provide?
Oh, I'm not sure. I'm not sure.
Just planting the seed, especially because we are trying to improve the engagement of our stakeholders and not only scientists, but also like we would like to work with other partners in the Gulf.
Oh.
Yeah. Quizás en español, pues, ¿cómo podemos mejor servir a usted, por ejemplo, que usted es un científico? ¿Cómo podemos servirle a usted con añadiendo data o algún tipo de conexión? ¿Cómo GCAN podría ayudarle a usted y a su investigación?
Okay, yeah. Okay, yes, thank you for the Spanish. So,
no problem.
For Mexico, it's very easy, I think. We have a lot of human resources. Also, we have university. We live in the. I am from the sea. We have boats. I think in general the main health is analyze the water samples. So not only for me, for a lot of I know another researcher that researcher wants to study ocean acidification, but the laboratory for Mexico is very expensive. That high level laboratory of CO2, for example, I don't measure this water sample. Maybe do you know Martina John from the UABC? No, it's from California. It's a college. So I don't measure this water sample. So I think a very good collaboration in a project, an international project, could be identify this very, very important area. So, for example, Términos Lagoon is one of them. Usumacinta River system is one of them. I don't know, in this area, in Veracruz, Cancun, a lot of this very interesting point. Also inside the land, like cenotes. So maybe a collaboration measurement this analysis TADAC pH could be a very, very good help for the researcher. So I think this is a bit. We don't have enough money for. We have the Martina John Laboratory, John Albert Sanchez Cabeza in the Mazatlan. They have good laboratories. They are another, but not too much. I think we have high human resources, but not too much measurement.
Yeah, and whoever said money can buy happiness didn't do science. Yeah. Dr. Yates also says, do any of the NOAA GOMEC transect lines approach the coastline near the study area? If so, that could help inform your model development. And we have a map in the GCAN webpage. If you go to gcus.org/GCAN, we have a tab that says monitoring and data, and we have an ocean acidification data map from the GOMEC series. Actually, we have the current GOMEC is the data that we have in that map is the GOMEC 3, but we are currently working on adding GOMEC 4. And there are some transects that are around Merida and then close to Términos, actually. So we have that data available. So GCUS and GCAN, we provide that data set, that we have the data. We're basically a database, and we have that data that could facilitate that. So this is a great opportunity. I feel like I'm selling a product, but this is a great opportunity.
Oh, no, thank you. Yeah.
Yes, this is a great opportunity. That's why we're here. So thank you, Dr. Yates. But yes, we can definitely provide. We have this data available that could perhaps complement your model. And if you'd like to share some data as well, we have that collaborative, that's our mission, to enhance collaboration with different sectors. So that includes stakeholders, academia, managers, so anything that has to do with acidification, water quality. That's our model. So we're here to facilitate those collaborations and also that data.
Good, so good. Yes, because my next step from I know, maybe this year, not this year, the next year. So I have now I have a result from the hydrodynamic model. I study this transport. I measure water age. So I have the hydrodynamic carbon data. So my next step is simulate the hydrodynamic carbon, the carbonate system. So yes, I need the frontiers from the model. So the carbon, your data will be very, very useful from the open boundaries. Yeah, another maybe doesn't work because the computer have a lot of problem. This is a repository from GitHub. I I don't know. It's for my students. I teach organic. I study marine chemistry in general. So I programming some exercise from calculate TA and DAC using pi CO2 system. You know, is CO2 is in Excel the regular CO2 sys. So this is from use pi CO2 sys, and you can change the. It's from my student, so maybe.
Actually, the QR code is not working, but if you keep up the web page, I think we can access it.
My code is not working.
No, it takes me to Binder.
Yeah, take 4 more minutes. Is Binder loading or?
It says loading. But I just access it through the web page so we can see it. I'm gonna copy and paste it in the chat.
Yes, maybe I can check that is for student. So
are there any more questions from the audience? Well, thank you, Dr. Cardoso, so much for this amazing presentation and this conversation as well. We're probably going to stay online and have just keep having a conversation. Thank you all for attending to this webinar. Just a couple of things that we're going to have. So GCAN is having a steering committee meeting next month. And also on January 8th is the Ocean Acidification Day of Action. And we will be having a webinar series with in collaboration with CARICAN, so the Caribbean Coastal Acidification Network, the µatm, which is the Mid-Atlantic Coastal Acidification Network, and SOCAN, which is the Southeast Coastal Acidification Network, and GCAN with the Gulf. So we will be having that as the Ocean Acidification Day of Action. We will have different topics from technical to education, and we're still working on the list of people of the speakers, but we would love to have everybody attend. It promises to be a very diverse webinar with the central topic of what kind of actions are we taking with ocean acidification. So again, that will be January 8th. The time is still TBD. But please, if you're not part of GCAN, please go to our webpage, gcus.org/GCAN, and you can become a member. We also have a live calendar of activities there that you can either subscribe to your Gmail or you can access, and it's updated weekly. And please follow us on Instagram and Facebook in the GCUS webpage. We will have updates as well posted in the social media. And if you're not part of our newsletter, the GCUS newsletter, we have also a GCAN corner where we plan to highlight scientists, educators, and anyone who's working with ocean acidification. So with that said, thank you all. If you'd like to join the conversation, I can gladly unmute you and you can join us. If not, then we'll see you next time.